Hi friends, welcome to all. In this video, we are going to configure this packet tracer activity, configure VTP and DTP. This packet tracer activity is from CCNA V8 N core. Friends, kindly request you to support us, subscribe, share and like our channel. And also if you wish to get any technical support, you can contact our team. All the details given in the description below. Now here in this activity, that is configure VTP and DTP, that is VLAN trunking protocol and dynamic trunking protocol. So here they given the addressing table and here we can see the topology. We got three switches S1, S2 and S3 and we can see the end devices here. And here they given the objectives. We will configure and verify DTP, then we will configure and verify VTP. We will go through this background or the scenario they given here. As the number of switches in a network increases, the administration necessary to manage the VLANs and trunks can be challenging. To ease some of the VLAN and trunking configurations, VLAN trunking protocol, that is VTP, allows a network administration to automate the management of VLANs. Trunk negotiation between network devices is managed by the dynamic trunking protocol, that is called DTP, and is automatically enabled on Catalyst 2960 series and Catalyst 3560 series switches. Here in this activity, we will configure trunk links between the switches, that means between S1 and S2, then S1 and S3. Then we will configure a VTP server and VTP clients in the same VTP domain. We will also observe the VTP behavior when a switch is in VTP transparent mode. We will assign ports to VLANs and verify end-to-end connectivity with the same VLAN. Here in part 1, we are going to configure and verify DTP, that is dynamic trunking protocol. So here we will configure trunk links among the switches. We will configure VLAN 999 as the native VLAN. In step 1, we will verify VLAN configuration. Verify the configured VLANs on the switches. On S1, click the CLI tab. At the prompt, enter enable and enter the show VLAN brief command to verify the configured VLANs on S1. And also we will repeat on S2 and S3 also. We will verify the configuration. First of all, we will go to S1, CLI, enable. We will give this command show VLAN brief, and here we can see VLAN 1, that is default VLAN, and we can see all the ports are in VLAN 1 here, and we can see VLAN 99, that is called management. The name of this VLAN is management, and here we can see VLAN 999 and the default name, that is VLAN 0999. And no ports are assigned to these VLANs. So we will go to the other switches like S2, go to CLI, enable show VLAN brief, and we can see the same thing here also. We got two VLANs created here, VLAN 99, that is management, and VLAN 999, and all the ports are in default VLAN. Coming to S3, okay, we'll give a show VLAN brief command. Here also the same. All the ports are in VLAN 1, default VLAN. Then two VLANs are created, VLAN 99 management and VLAN 999. So what VLANs are configured on the switches? Yeah, we verified on all three switches S1, S2 and S3 already configured VLAN 99 and VLAN 999. In step 2, configure trunks on S1, S2 and S3. Dynamic trunking protocol, that is DTP, manages the trunk links between Cisco switches. Currently, all the switch ports are in the default trunking mode, which is dynamic auto. Okay. In this step, we will change the trunking mode to dynamic desirable for the link between switches S1 and S2. For the link between switches S1 and S3, the link will be set as a static trunk. Use VLAN 999 as the native VLAN in this topology. So this VLAN 999 is already created in all three switches. And here they specified all the switches are in a default trunking mode, that is in dynamic auto. Even we can verify that using the show command. For example, we will verify show interface, we'll give a FA0/1, a switch port. So here we can see administrative mode. So it's in dynamic auto. So all the ports are in dynamic auto by default. On switch S1 and S2, configure the trunk link to dynamic desirable on the gigabit Ethernet 0/1 interface. The configuration of S1 is shown below. Okay, this is what we need to configure on S1. Interface G0/1. So which is connected to this S2. Switch port mode dynamic desirable. We will do that on S1. Configure terminal. Then we will go to interface G0/1 and we will give that command. Switch port mode dynamic desirable. Then for the trunk link between S1 and S3, configure a static trunk link on the gigabit Ethernet 0/2 interface. So we are going to configure on S1 and S3 on the interface G0/2. So first of all, we will go to S1. Then we will go to the interface G0/2. Switch port mode trunk. Okay. Then on S3, enable configure terminal. We will go to interface G0/2, switch port mode trunk. Verify trunking is enabled on all the switches using the show interfaces trunk command. What is the native VLAN for these trunks currently? Okay, we will verify that. First of all, we will go to S2, enable show interfaces trunk. So here we can see mode is auto because we configured trunking on the other side on S1. So here we can see mode is auto, automatically created trunk. Then encapsulation status is trunking. Okay, native VLAN is 1. And we can see the interface G0/1, which is connected to this S1. We will verify on S1. Show interfaces trunk. And here we can see those two interfaces we configured trunking, G0/1 and G0/2. So we can see the mode desirable and here it is on. Here we given mode as a dynamic desirable, and for the interface G0/2 we given static trunk, that is mode as a trunk. So we can see the mode is on. Status is trunking, native VLAN is 1 in default. And finally, we will verify on S3. Show interfaces trunk. And here we can see mode is on because we configured a static trunk on S3, interface G0/2. Encapsulation status is trunking, and we can see native VLAN is in default to VLAN 1. Okay, next configure VLAN 999 as the native VLAN for the trunk links on S1. and that is on G0/1 and G0/2. So here they given the command interface range G0/1-2 switch port trunk native VLAN 999. So what messages did you receive on S1? How would you correct it? Okay, we will give this command and we will see how we get that mismatch discovered. Configure terminal. We will go to those interfaces. Interface as a range G0/1-2. That means two interfaces G0/1 and G0/2. So here we are going to configure switch port trunk native VLAN 999. And here we can see immediately we get an message, error message received BPDU with the inconsistent peer VLAN ID 1 on gigabit Ethernet 0/1 VLAN 999. Native VLAN mismatch discovered on G0/2 with the S3 G0/2. So because we need to configure this same native VLAN ID on the other switches also, I mean on S2 and S3, so that we can avoid this mismatch. On S2 and S3, configure VLAN 999 as the native VLAN. Yes. So once we configure that, we can correct this native VLAN mismatch issue. So we will do that. We'll go to S2. Then we will do it. Enable configure terminal. We will go to interface G0/1. So we can see G0/1 connected to S1. Switch port trunk native VLAN 999. Even we get that message in this S2 also, native VLAN mismatch discovered on gigabit Ethernet 0/1. Now we will do it on S3. Enable configure terminal. We'll go to interface G0/2. Switch port trunk native VLAN 999. And once we give that command, we can see unblocking gigabit Ethernet 0/2 on VLAN 0999 port consistency restored. So that problem is resolved. That is native VLAN mismatch. Verify trunking is successfully configured on all the switches. You should be able to ping one switch from another switch in the topology using the IP address configured on the SBI. Okay, we will verify that. So first of all, we'll go to S1, show interfaces trunk, and we can see that native VLAN is now 999. Then coming to S2 and show interfaces trunk, native VLAN is 999, correct. Then coming to S3, show interfaces trunk, native VLAN is 999. Now we will ping from one switch to another. We will ping from S1. Okay, let me get the IP address of S2. Show IP interface brief. So here we can see the IP address 192.168.99.2. So we'll ping from S1. Ping to S2. So we are waiting for the replies. Yeah, so success rate is 60%. We will try once more. We'll ping again. So we can see success rate is 100%. Next, we will get the IP address of S3. Show IP interface brief. And we can see it's 99.3. So we will ping to 99.3. And here also we may get 1 or 2 request timed out. Success rate is 60%. Okay, once more we will try. So success rate is 100%. Next we will go to part 2, configure and verify VTP, that is a VLAN trunking protocol. S1 will be configured as the VTP server and S2 will be configured as a VTP client. Okay. All the switches will be configured to be in the VTP domain CCNA and use the VTP password as Cisco. Then VLANs can be created on the VTP server and distributed to the other switches in the VTP domain. Yes. So once we convert to client, we cannot create any VLAN in that particular switch. So we must create these VLANs only in the server. So in this part, we will create 3 new VLANs on the VTP server. That is S1. These VLANs will be distributed to S1 using VTP. Observe how the transparent VTP mode behaves. So we will also configure this transparent VTP. Step 1, configure S1 as VTP server. We are going to configure S1. Configure S1 as the VTP server in the CCNA domain with the password Cisco. So we need to configure all these. So configure S1 as a VTP server, VTP mode server. So we are going to change the mode, setting device to VTP server mode. Okay. Then we will do the VTP domain as CCNA and also we will set the VTP password. So before configuring, just we will verify show VTP. We can check the status. So this S1 is in transparent mode. Okay. So we are going to change this mode in global configuration mode, configure terminal, and we will set VTP mode server. So setting device to VTP server. Okay. Then configure CCNA as the VTP domain name, that is VTP domain CCNA. So we will give that VTP domain CCNA. So VTP domain name changed to CCNA. Then we will set the password as a Cisco, that is VTP password Cisco. VTP password Cisco. Setting device VLAN database password to Cisco. Exit. Show VTP password. We can verify password also. Show VTP password. We set the password as Cisco. Then we have a show VTP. Let me put a question mark. Even we can see the counters here. Anyway, we did not configure the VLANs. So we will verify the status again. And we can see VTP operating mode is in server. And we can see VTP domain as a CCNA. In step 2, verify VTP on S1. Use the show VTP status command on the switches to confirm that the VTP mode and domain are configured correctly. To verify the VTP password, use the show VTP password command. Yes, both be given in this switch S1. So just parallelly we will verify it on S2. Show VTP status. So we can see it is in transparent. We'll verify on S3 also. Show VTP status. It is in transparent mode. In step 3, add S2 and S3 to the VTP domain. Before S2 and S3 will accept VTP advertisements from S1, they must belong to the same VTP domain. We already configured a VTP domain as CCNA on S1. So configure S2 as a VTP client with CCNA as the VTP domain name and Cisco as the VTP password. Remember that VTP domains are case sensitive because we given in capitals. So that should be the same in the other switch when we configure the client. Okay. Configure S2 as a VTP client in the CCNA VTP domain with the VTP password Cisco. So here they given the command on S2 VTP mod client, then VTP domain CCNA and VTP password Cisco. So we will do that on S2. Configure terminal and we will give the VTP mode as client. Oh, I given VTY. It's a VTP mode client. So setting device to VTP client mode. Then we will set the VTP domain as CCNA. So it should be the same as we given in the server. Domain name old is set to CCNA. Okay. Then we will set the VTY password as Cisco. Oh, again I given VTY. It's a VTP. VLAN trunking protocol. VTP password Cisco. So setting device VLAN database password to Cisco. To verify the VTP password, use the show VTP password command. Show VTP password. Okay, we will verify that. Exit. Show VTP password. Okay. Also, we will verify show VTP status. So operating mode is client, and we can see VTP domain name is CCNA. So configure S3 to be in the CCNA VTP domain with the VTP password Cisco. Switch S3 will be set in VTP transparent mode. Okay. So we will set S3 as VTP transparent. So VTP mode transparent, VTP domain CCNA. Also we will set the VTP password as Cisco. Coming to S3, configure terminal, VTP mode transparent, device mode old VTP transparent. Okay. VTP domain CCNA, VTP domain name changed to CCNA. Okay, perfect. Then VTP password Cisco. Exit VTP status. Sorry. Show VTP status. We can see operating mode is in a transparent, domain name is CCNA. Also we will verify. Show VTP password. Password is Cisco. Enter show VTP status command on all the switches to answer the following questions. Notice that the configuration revision number is 0 on all 3 switches. Explain. So we will verify this revision number on all 3 switches. And this revision number will change only whenever we do any VLAN addition, or if we do any deletion, or if you modify any VLAN. So then this configuration revision number will be increased. Just we will verify that. Enable show VTP status. So configuration revision is 0. Okay, because we did not create or we did not delete or modify any VLAN on any switch. And here itself we can see configuration revision is 0. We already given this show VTP status. Then on S3, configuration revision is 0. So we did not do any modification, or we did not add any VLAN in the server switch. So just to keep in mind, the configuration revision number will increase by 1 every time whenever we add a VLAN, or when we delete a VLAN, or whenever we modify a VLAN. So now in step 4, create more VLANs on S1. Yes, this is our server. So on S1, create VLAN 10 and name it red. That is VLAN 10, name red. So create VLAN 20 and 30 according to the table below. So we are going to create these VLANs and we are going to name those VLANs as per this table. So we will do that on S1. Configure terminal. We will create VLAN 10 and we will give the name as red. Then VLAN 20, name as blue. Then VLAN 30, name as yellow. So these are the information they given in the table. Now verify the addition of the new VLANs. Enter show VLAN brief at the privileged exit mode. Which VLANs are configured on S1? Okay, we already created these 3 VLANs. Show VLAN brief. Show VLAN brief. And we can see we created these 3 VLANs again. VLAN 10, VLAN 20, VLAN 30. So already we have these VLANs previously, VLAN 99 and VLAN 999. So we created and we named these 3 VLANs. So confirm configuration changes using the show VTP status command on S1 and S2 to confirm that the VTP mode and the domain are configured correctly. Output for S2 is shown here. So how many VLANs are configured on S2? Does S2 have the same VLANs as S1? Explain. So we will verify that. First of all, we will go to S1. Show VTP status. And here we can see configuration revision is now changed from 0 to 6 because we created VLAN, that is 3 VLAN, and we modified the name. So total 3 plus 3 is 6. So we get the configuration revision as 6 here. We can verify it on S2 also. We already seen configuration revision initially was 0. We will see now what is the change. Show VTP status. So here we can see configuration revision now it's a 6. We can verify show VLAN brief command. We can see those 3 VLANs are here in the VLAN table, which is come from our server, that is S1. So here we can observe that whenever we create or modify or delete anything on the server, which will be affected, which will be reflected in the client also. So S2 is our client, S3 is in transparent. So just we will check in S3 also, show VTP status. So here we can see configuration revision still in 0 because it is in transparent. Show VLAN brief. And here we can see only those 2 VLANs created early. So now on S2, whatever VLANs we created on S1, that is reflected in the S2. So here we have seen that VLAN 10, VLAN 20 and VLAN 30 is available in the S2 switch also. Next is observe VTP transparent mode. S3 is currently configured as VTP transparent mode. Yes. And use a show VTP status command to answer the following questions. Already we given that command. How many VLANs are configured on S3 currently? So we have seen those previously configured VLANs, that is 99 and 999, already built-in configured. And those VLANs we created in the server, which is not reflected here because S3 is in transparent. So what is the configuration revision number? It is in 0. So explain your answer. Yes, that is the answer. So how would you change the number of VLANs on S3? So we can see we have the server. So we must change or convert this S3 as the VTP client so that all the VLANs we created in the server will reflect in the switch S3 also. Yes. Now change VTP mode to client on S3. Okay. Now we are going to change the mode from transparent to client on S3. Then use show commands to verify the changes on the VTP mode. Then how many VLANs exist on S3 now? Okay, we will do that. Coming to S3, configure terminal, and here we will give a VTP mode as a client. Okay, now we will verify and show VTP status. So now we can see the configuration revision is 6. So whatever we configured on the server is reflected in the client, that is S3 also. Show VLAN brief. We can see now VLAN 10, VLAN 20, and VLAN 30 is in the VLAN table on S3. We created 3 VLANs in our server, that is on S1, and those 3 VLANs come to the client also, that is on S2 and S3. So VTP advertisements are flooded throughout the management domain every 5 minutes or whenever a change occurs in VLAN configurations. To accelerate this process, you can switch between a real-time mode and a simulation mode until the next round of updates. However, you may have to do this multiple times because this will only forward packet tracers clock by 10 seconds each time. Alternatively, you can change one of the client switches to transparent mode and then back to client mode. Okay, you can try that also. Now we'll go to step 6. Assign VLANs to ports. Use the switch port mode access command to set access mode for the access links. Use the switch port access VLAN, then VLAN ID command to assign a VLAN to an access port. So here in this table, they given all the details. Port assignments. VLAN 10, that is red, network is 192.168.10.0/24. So on S2, from FS0/1 till FS0/8. Then on S3, FS0/1 till 8. Then for other VLANs, VLAN 20 and VLAN 30, we can see the ports we need to add in the respective VLANs. So assign VLANs to ports. So we will assign these VLANs, VLAN 10, VLAN 20, and VLAN 30 to its respective ports on S2 using assignments from the table above. So here they given for the S2. So we need to do it on S3 also. So we will do that on S2 first. Okay, I will keep it here so that we can see these ports here. Configure terminal. We will go to interface as a range. So we can see FA0/1-8. Okay. So we will give a switch port mode access. Then we will give a switch port access VLAN 10. Okay. Next we can see on S2 from FS0/9 till FS0/16. So we'll go to interface as a range FS0/9 till 16. A switch port mode access switch port access VLAN 20. Then here we can see the remaining ports, that is FS0/17 till 24 in VLAN 30. So we'll give interface as a range FS0/17 till 24. A switch port mode access switch port access VLAN 30. Okay, just will end. Copy, run, space, start. We can verify these configuration, right? So coming to S2, show VLAN brief. So here we can see from 1 to 8, it is in VLAN 10. Then 9 to 16 is in VLAN 20. Then from 17 to 24, it is in VLAN 30. And G0/1 is trunking. And we can see G0/2 is in default VLAN. So assign VLANs to ports on S3 using assignment from the table above. Okay, we will do it on S3. Configure terminal. We will go to interface as a range FA0/1-8. Switch port mode access. The switch port access VLAN 10. Next is from 9 to 16. Interface as a range FA0/9 till 16. Switch port mode access. Switch port access VLAN 20. Right. Switch port access VLAN 20. Then we will go to interface as a range FA0/17 till 24. 17-24. Switch port mode access. Switch port access VLAN 30. So we can verify this. End show VLAN brief. And here we can see from 1 to 8 in VLAN 10. 9 to 16 is in VLAN 20. 17 to 24 is in VLAN 30. And G0/2 is trunking, and we can see G0/1 is not assigned to, it is in default to VLAN 1. Step 7, we need to verify end-to-end connectivity, but before that, we can see our completion status shows only 96%. So here, in this instruction, we can see in step 2, part 1, step 2, here we can see on switch S1 and switch S2, we must configure on S1 and S2. So here they given only for the S1, we need to configure on S2 also this dynamic desirable. Switch port mode as dynamic desirable. So we will configure on S2 also. Just I will go to S2. Okay. Configure terminal. We will go to interface G0/1 and we will configure a switch port mode dynamic desirable. Okay. End. Copy, run space, start. Okay, now we can see here completion status is 100%. And finally, we will verify this end-to-end connectivity. From PC0, ping PC5. So we'll get the IP address of a PC5. So we can get from here. We will ping from PC0. So we get the replies. Then from PC1, ping PC4. So we'll get the IP address. From PC1, we ping to PC4, we get the replies. Now we will ping PC2 and PC3. We will get the IP address from PC3, or even we can get from our addressing table. So we'll ping from PC2. So here we ping the same VLAN. So we get the replies. Perfect. So that's all in this video. That is configure VTP and DTP. So we'll meet again in the next video. Thank you.